In this video, we're going to be covering polynomial inequalities. So pretty much polynomial inequalities are helpful because we can learn when the graph of a certain polynomial is above or below the x-axis without even graphing it. So what we're going to do is that you could solve two different types of inequalities. If you solve the inequality when it's greater than or equal to 0, that actually shows you when the graph is above the x-axis. Now, on the contrary, if you solve the problem for when it's less than or equal to 0, it shows you where the graph is below the x-axis. So pretty much that makes sense, right? So if it's greater than, which means positive, it shows you when it's above. And if you solve for less than, which means negative, means when the graph is below. So let's go ahead and start with a few examples here, right? So here we have a graph, and they're asking us to read the graph so we could find where the graph is less than 0. So pretty much what this means is where is the graph below the x-axis, right? And then eventually we're going to have to find where is it greater than 0. So where is it above the x-axis? So that's what pretty much that means. So let's go ahead and just cut our graph into pieces, right? So here, from here to here, I'm going to draw a line. From here to here, the graph is below the x-axis, right? So the graph is below. And what number is this right here? This number right here is -3. Now, from here, I follow the graph from here all the way to this point here. The graph is above the x-axis, okay? And it's at 0. Now, from here all the way to here, to this right here, I'm going to just pretend that's straight. Here, the graph is below the x-axis. I'm going to put a B for below. And then starting here, which is at 1, 2, 3, the graph is always going to be above the x-axis. So what I did is that I cut the graph into 4 different pieces. Those are going to be my intervals. So let's go ahead and answer the question. From where is the graph? See, nowhere here does it say below, but we know that that's what this symbol means. So where is the graph below? This is our answer. It's going to be this little piece right here, which is from -infinity to -3. That's how I got that. And then it was also below in this part, which was from 0 to 3. So that's how I got my second part. Now, this is a new symbol that you're going to see. When you have two different answers, you're going to unite them with this little symbol that means union. So from now on, just remember to put a little U in there. Okay, my answer for the following question, where is the graph above? It was from here to here, which is from -3 to 0. And then it was also from 3 all the way to infinity. Okay, and again, we unite them with the little U symbol. And there you go. That's pretty much what you have to do. Just remember to split your graph into little pieces. So let's go ahead and try one more here. Again, where the graph is, remember below 0 means where is the graph below the x-axis. Interval where the function is greater than 0. So where is it above? Okay, so let's go ahead and split our graph. So here the graph is above the x-axis, above, above, above. Here it starts going below. So I'm going to cut the graph right here. And the number right here is -3. Now here the graph is below, 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 and then here it crosses. So I'm going to cut the graph right there. So here we said it's above, here it's below. Now here the graph, let me go ahead and just write that number, that's -1. Now here the graph is above, 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 above. Here is the x-axis, so here's where it stops being above. Now here this number is 1. Now here it's below, 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 below. Here it cuts again, so I'm going to cut it right here. So from here to here it was below. And this number right here is 2. Now here the graph is above the x-axis and it's never come back down. So this last part is above. Okay, so now that I cut my graph, I could answer the question. Where is the graph below? It was from, it's this little chunk right here from -3 to -1. And it was also right here from 1 to 2. So that's my answer for the first part. Now, where is the graph greater than 0 or above? It's going to be this chunk right here. This first part is, remember, it's from negative infinity to negative 3. It was also above from negative 1 to 1. And it was also above from 2 all the way to infinity. Okay, pretty simple. Now, how do we solve an inequality when we don't have a graph? So this is going to take us several steps. Step number 1, when you are presented with an inequality, first thing you have to make sure is that the right side is 0. Your inequality always has to have a 0 on the right side. Step 2, you're going to have to completely factor out the left side. So now that everything is on one side, you're going to have to factor it out. Step 3, you're going to set each factor equal to 0, and we're going to call these answers boundary points. Okay, again, don't worry if this doesn't make sense. Step 4, you're going to create a number line with all of your boundary points. So if you only end up with one boundary point, then just 1 point. But if you have multiple, you're going to have to put them in order in a number line. Now, step 5, we're going to test a point in each interval. Okay, again, just make sure you write down the steps. We're going to go into depth in just a few minutes. All right, in case you had forgotten this already, when we use different symbols, it denotes what kind of parentheses or brackets we're going to be using. So just as a reminder, if you have a less than or a greater than, we always use parentheses. If we have a less than with an equal to or a greater than with an equal to, we use brackets. Okay, so make sure you have that jotted down. And as a reminder, when we have infinity symbols, we always use parentheses regardless of what symbol we have. Parentheses always go with infinities. All right. And then one more note here, if you have forgotten already, every time we multiply or divide by a negative number, remember that the inequality flips. This is very important. So for example, if I want to solve this inequality here, I have to divide both sides by -4. So obviously on the left side, the -4's cancel, leaving me with just x. H divided by -4 gives me -2, but look what happened to the symbol. Since I divided by a negative number, the symbol has to flip. Okay, if it's an equal to, it still stays as an equal to. If it doesn't have an equal to, you don't have to give it an equal to, but just remember that it flips. So if it was facing to the right side, now it's facing to the left side. Okay, that was just a little note to remember. So let's go ahead and tackle some of these problems out. So here we go, right? Solve the inequality and write your answer one internal one notation. So step number 1, we have to have a 0 on the right side, which we already do. So check. Step 2, this has to be factored out. You know it's factored out because it's already in parentheses. So that's check also. Step 3, I'm going to set each of these factors equal to 0. And these are going to be my boundary points. So what I do is I set this equal to 0, which obviously is just going to flip it. So it's going to be +7. I'm going to set this equal to 0, which is going to give me -10. And I set this equal to 0, which is going to give me +8. These are our boundary points. Okay, so if you want to make a little label, these are going to be the points that go on the number line. And obviously that's the next step. Create a number line and you put them in order. Make sure they're in order. So we have -10 first, and then we have the 7, and then lastly we have the 8. So this is what happened. Our number line was split into different parts. So we have a total of 1, 2, 3, 4 parts. Each part represents an interval. Okay, and then the last step means that we're going to have to test a point from each interval. This is what this means. Okay, so just bear with me. The first interval is denoted by, remember, what goes all the way over there? -infinity, and then it stops at -10. This is the first piece. Now, infinities always go with parentheses. And now, why did I use a bracket here? Because remember the symbol. If that symbol has an equal to, we're going to use a bracket. Now, you're going to have to choose whatever number you want here. -10, you could use -11, -12, -13, all the way to -infinity. So you could choose any number you want. You could use -1567 if you want. But I chose something super simple. I used the number right next to it, negative 11. Now, once you choose a number, you're going to replace that number in all the x's in the original problem. So if you notice, I did negative 11 minus 7, negative 11 plus 10, and then negative 11 minus 8. You input all of this into your calculator and you write down the answer you got. Okay, so I put all of that in my calculator just the way you see it there, and I got negative 342. And then all I care is to see if this satisfies the inequality. So I'm going to ask myself, is this number less than or equal to 0? My answer is yes. This number is less than or equal to 0. So that means that this right here is going to be one of my answers. Okay, only because the number that I got here is less than or equal to 0. Now, regardless, if you would have chosen, like I said, negative 100 or 1,567, you would have gotten, of course, a different number than me. But again, we would have both had numbers that were less than or equal to 0. So that's all I care about. Okay, so that's what we do. Now, of course, now we go on to the second part. From here to here is negative 10 to 7, both with brackets because, again, because of the symbol. Now, you choose whatever number you want from here to here. Some of you will choose negative 9. Some of you would choose 5. If you can choose 0, always choose 0. So 0 falls from negative 10 to 7, so I chose it. If I put 0 in all the x's, as you can see here, put it in your calculator, I got 560. Now ask yourself, is 560 less than or equal to 0? No, so that means this is not going to be one of my answers because it's not less than or equal to 0. Okay, I'm hoping this is making sense. So as of right now, this worked. This did not work. Now let's try the next one. The next one's going to be from 7 to 8. You could choose whatever number you want, but we're very limited. From 7 to 8, there's no whole number, so I had to go with the decimal. But it's okay, don't worry. Now that decimal, you put it in all the x's. I'm going to have 7.5 minus 7, 7.5 plus 10, 7.5 minus 8. Put that just the way it looks into your calculator, and I got negative 4.375. Again, I don't care at all what the number is. All you have to check is that number less than or equal to 0? Because it's negative, yes it is. It's less than or equal to 0, so that means that's going to be another one of my answers. Okay, now the last part. The last part is from 8 to infinity. Again, infinities always go with parentheses. Now you could choose whatever number you want. 8, you cannot use 8, but you could use 9, 10, 11, 12, 13, 14, all the way to infinity. So if for some reason the number 3,584 is your favorite number, you could use that number. But again, to keep things simple, I used a 9. Just like we've been doing, I'm going to replace the 9 into the original equation. So 9 minus 7, 9 plus 10, 9 minus 8. Put it that way in the calculator, and I got 38. Again, I don't care what the number is, just the fact that it's not less than or equal to 0. So this is not going to be my answer. So our final answer are just the intervals that worked. So my final answer is this interval right here and this interval right here. And just like I mentioned earlier, when you have more than one interval, you put the little union in the middle. Okay, so I'm hoping this made sense. If you notice, everybody here is going to have different numbers because like I said, you could choose whatever numbers you want. But at the end of the day, we don't care about the number you chose. We don't care about the number you got. We just care if it worked or not. And your answer is going to be the interval itself, not the number that you chose. All right, if that didn't make sense, we have a couple more examples. Let's go ahead and try one more. Again, just follow your steps. Step 1, we're supposed to have a 0 on the right side, which we already do. Step 2, the left side has to be factored out. This right here is not factored out because it's not in parentheses, but we are already masters in factoring. In order to factor this out, we're going to have to find two numbers that multiply to 6 and add to negative 5. Again, that goes back to our lesson in factoring. If you need help with that, let me know, or you can just go back to the video on factoring. So two numbers that multiply to 6 and add to negative 5 are negative 2 and negative 3. So this right here is the factored form of the top one. Now, just like we did on the other one, now that it's factored, I set those equal to 0, and I'm going to get positive 2 and positive 3. Those are going to be my boundary points. So I create my number line. On this case, it's going to be a little bit more simple because I only have 2 numbers, but I'm going to have 3 intervals. So just like I did with the other one, my first interval is going to be from negative infinity to 2. Now, why did I use a parentheses? Because remember, this symbol doesn't have an equal to on the bottom. So now I'm going to use parentheses everywhere. Now, what number can I use from negative infinity to 2? I could use the number 1, right? Because 2, and then what's right next to the 2? The 1, and then the 0, and then also on and so forth. So like I said, you could have used 0, you could have used negative 1, you could have used negative 100, I don't care. So in this case, I use a 1. Now, you could replace the 1 in either this one or this one, wherever you want. You're going to get the same answer. So I went ahead and replaced it on the first one. So I'm going to do 1 squared minus 5 times 1 plus 6. Put that straight in your calculator, and I got 2. Now ask yourself, is 2 less than 0? No, it's not less than 0. So this is not going to be one of my answers. Now we just finished this problem. So my next interval is from 2 to 3. What number can I choose from 2 to 3? Again, I'm very limited. I'm going to have to go with 2.5. Come back and replace it. So I'm going to have 2.5 squared minus 5 times 2.5 plus 6. Put that straight in your calculator, and I got negative 0.25. Again, ask yourself, is negative 0.25 less than 0? The answer is yes. Since it's negative, it's less than 0. So that's one of my answers. Okay, let's go ahead and finish this problem out. The last interval is from 3 all the way to infinity. You could choose whatever number you want. To keep it simple, I just use the number right next to it, which was 4. Replace it, put it in my calculator, and I got 2. Now my question is 2 less than 0? No, it's not less than 0. So in this problem, I only had one solution, which was this interval right here. Okay, pretty simple, and of course you do have to show all your work. All right, let's go ahead and do one last problem. Here we have something a little bit messier, right? We have our inequality, we have things on the left, things on the right. So step number 1, we have to have a 0 on the right side. So here we're gonna have to move things around, but it's simple, right? All I'm gonna do is I'm gonna throw this to the left side, but if I do that, it's gonna become negative. And I'm also gonna throw this to the left side, but obviously it's going to become positive. The negative y to the third didn't change sides. It's still on the left side, so that's why it stayed the way it was. Now, once these two move to that side, I'm finally left with a 0 on the right side. So that's step number 1. Now, there's something else. Before we move on to step 2, which is factoring, remember, we never like to have a negative in the front, ever. So what we're going to do is that we're going to divide everything by negative 1. Every time you want to change the signs of something, remember, divide by negative 1. Now, what I do to one side, I have to do to the other. So I'm going to divide by negative 1. Now, hopefully, you remember this. What happens when you divide by a negative 1? Or by a negative number? This is what happens. So the point of dividing by negative 1 is so everything would change sign. This one became positive. The 10 became positive. The 11 became negative. And the 0, of course, just stays as 0. But if you notice, since we divided by a negative number, the sign flipped. Okay, that was a big deal. So just make sure you caught that. Okay, now we can move on to step number 2. Step number 2 says factor. You should notice that all of these share a y. So I factor out the y. And then I could factor out the remaining polynomial by the product and sum. So two numbers that multiply to negative 11 but add to positive 10 would be positive 11 and negative 10. So again, this is the factored form. Again, I'm not going to go into depth because we already had a whole lesson about factoring. So if you need help with that, again, come to me and let me know. Now, once it's already in factored form, the next step is to set those factors equal to 0 so we could get our boundary points. So these are going to be my boundary points. If I set this equal to 0, I'm going to get 0. If I set this equal to 0, I'm going to get negative 11. And if I set this equal to 0, I'm going to get the positive 1. Those are going to be my boundary points. Now, with my boundary points found, I could create a number line. Remember, when you do the number line, they always have to be in order. So I'm going to have the negative 11 first, and then the 0, and then the 1. And it's always going to be the same procedure. So let's go ahead and get started. My first interval is going to be from negative infinity to negative 11. Now, infinities go with parentheses. The 11 is going to go with a bracket because, again, the symbol has an equal to on the bottom. And same procedure over and over again. Choose whatever number you want. I chose the one right next to it, which was negative 12. And I replaced it into the original one. Again, you don't want to use this original one. Make a note of it because this one doesn't have a 0. You have to use the one that has a 0 on the right side. Okay, so I went ahead and used, just so you know, make a little note of it. You could use either one of these two. Okay, we cannot use this one either unless you really want to, but we don't like to use it. I wouldn't recommend because it has a negative. You could use this one that was already done, or you could use the factored one. So you could use either one of these, but I'm going to go ahead and use this one right here. So I replace it with the negative 12, so I'm going to have negative 12 to the third power plus 10 times negative 12 squared minus 11 times negative 12. Put that straight in the calculator, and I got negative 156. To be honest, I don't even care about the number. I just care the fact that it's negative. So is that greater than or equal to 0? No, it's not. So that's not my answer. Let's move on to the next one. Next interval is from negative 11 to 0. I could choose any number I want. I chose negative 1. I replaced it into the problem, as you can see here. Put it straight in my calculator, and I got positive 20. Is positive 20 greater than or equal to 0? Yes, it is. So it is greater than or equal to 0. Next interval is from 0 to 1. Again, I'm very limited. There's no whole numbers from 0 to 1, so I chose right in the middle, 0.5. I replaced it into all of the y's here. So 0.5 to the third plus 10 times 0.5 squared minus 11 times 0.5. Put it in the calculator. I got negative 2.875. It's negative, so is that greater than or equal to 0? No, it's not. It's not greater than or equal to 0. So far I only have one answer. The last interval is from 1 to infinity. You could choose whatever number you want. I chose 2. I put that into the polynomial on this side, so I'm going to have 2 to the third plus 10 times 2 squared minus 11 times 2. I got positive 26. Is positive 26 greater than or equal to 0? Yes, it is. And that's it. So what's my final answer? I have two answers. I have this interval from negative 11 to 0, and I have the interval from 1 to infinity. And of course, we unite them with a little union set.